This month's seminar, and it gives me great pleasure actually to welcome Kelley Wilder, who's Professor of Photographic History and Director of the Photographic History Research Centre at the Montfort University. She's published extensively on science and photography, and most recently a paper called Photograph, Science and Expanded Notebook, and I'll put the link for that into the chat box in a minute. And that's an excerpt from a book that she's currently working on, which is provisionally titled Doing Science in a Photographic Age. And I presume what we're about to hear is going to be part of that as well, on John Herschel's chemical experiments. Kelley.
Thanks so much, Frank. And thank you everyone for all the quick thinking, the fast electronic footing, for getting us all online. I really appreciate you having me to talk about this work, because it's very much work in progress. And I'm hoping for a good discussion and lots of questions and maybe observations about the history of chemistry. I thought this is a great forum for me to get some good feedback, because thinking about Herschel has been something I've been doing for a very long time, since I wrote part of my PhD dissertation on Herschel and didn't understand him then, and I'm not sure I understand him any better now, but I still enjoy working on him. Part of the research that fed into this particular paper will be appearing in a chapter for a Herschel companion on photography, Herschel's photography. And that chapter concentrates on a sort of overview of Herschel's photography. But instead, I really wanted to consider Herschel's chemical experimentation as a longer and broader consideration within chemistry in the 19th century. And Herschel's chemistry spans very much of it spans 50 years or 60, almost 60 years of the 19th century, which is seems like a really sort of problematic time for chemical knowledge and theory. It's a time when there's a lot of change, and there are many more chemists becoming chemists, professional chemists, the rise of industrial chemistry, a whole lot of changes in ideas and theories about what chemistry was what chemical changes were being shown. And I think in the discussions, Herschel's experiments show us some interesting things that I'm not sure what I think about them, and I'm hoping we can have a conversation about that. On the whole, we understand Herschel's chemical experiments in terms of photographic history, and I think that has a few limitations. The limitations are that those are generally driven by the emphasis on origin stories of photography, that they emphasize other photographic practitioners at the expense perhaps of, say, chemical suppliers or chemists, or people who are working on chemical theories or philosophers of science. And I think the third thing that it does is it takes far too much interest in the sort of pictorial end of Herschel's chemical experiments. So those things that ended in pictorial images, especially those that were fixed pictorial images. And most of Herschel's experiments are not pictorial, and they don't end in these kind of conventional things that photographic historians in the past have paid attention to. I think that Herschel, I'm going to say photography occasionally in this talk, but I really mean his full experiments. And for Herschel, the title photography is a sort of collective heading that gathers together all his chemico-optical experiments from the 1810s through nearly 1860. And in this group of experiments, Herschel made a systematic use of photographies for spectral analysis and chemical sensitometric testing a long time before the photochemical work of Roscoe and Bunsen in Manchester, and even longer before Herder and Driffield, who became, between them, probably established some of the fundamental benchmarks in the field of photochemistry and sensitometry. So if you're wondering why I'm interested in looking at Herschel in terms of chemistry, I'm really interested in some of the fundamental ideas behind experimentation that eventually would push into understanding and standardizing photographic materials. So for me, that's what's interesting. I'm sure there'll be other things to be interested in. And when I was reading Steve Case's wonderful book, Making Stars Physical, he points out that Herschel noticed that photography in the conventional sense was separating from his experiments on photochemistry sometime during the 1850s. And he started differentiating his use of photography for light experiments from those things which he called actochemistry, from photography for making optical images, that is pictorial stuff that other people called photography. So the extent of Herschel's, oh, I'm supposed to be sharing my screen so you can look at pretty pictures. So sorry, I forgot to do that. I'll just do that. My work today really focuses on 3 sets of materials, and Herschel's chemical experiments are extremely diverse, and maybe they're a little bit less known and less understood than many of his other strands of research, like his astronomy. And maybe it's good for us just to have a brief tally for those in the audience who don't know Herschel as well, so that we can understand what kind of output he had. So he published at least 9 important articles on photographic chemistry between the years 1819 and 1858. He introduced hyposulphite as a fixer and 7 new imaging processes, depending on how you count them, among them the cyanotype, which, as it became commonly known, was the blueprint. He produced negatives on glass. He's well known for popularizing important vocabulary, namely photography. He didn't invent it, but he popularized it, snapshot, negative, and positive. And even more importantly, he was instrumental in supporting a sort of thriving network of individuals who are now considered photographic pioneers and photochemical pioneers. And this network becomes quite interesting. And as we go onwards and study Herschel more, I'm sure that we're going to come up with a very interesting, slightly new network of associated people that have to do with the history of chemistry, perhaps more than photography. Mike Ware has already pointed out that one of the reasons why Herschel's work is less known in the chemical area is that his notebooks, which contain the bulk of these materials, are largely loose leaf and not always in bound notebooks. And I'm showing you one of them now at the HRC in Texas. And this one's called Photographic Memoranda. The next one is a repository of spectra, and also at the HRC. And then there are many, many, many loose leaf pieces of paper that just have chemical notes in them. And these were not always transcribed into his main notebooks. But of course, we know the Science Museum notebooks. Here's notebook 1, the early experiments. But you know that there are several notebooks in the Science Museum that do have chemical experiments and photographic experiments. Some of them map onto some of the loose leaf papers, but it's not so clear which ones do. Still working our way through that. And hopefully in the future, we'll be able to digitize some of that and bring them together, which would make understanding Herschel quite a lot easier. So the collection is dispersed across the Royal Society, the History of Science in Oxford, the Harry Ransom Center, and the Museum of the History of Science, and 2 institutions within the Science Museum group, one at Bradford and one in London, of course. What we do know about Herschel's chemistry and chemical experiments is in large part due to Mike Ware and Larry Schaff, who both have written extensively about Herschel, and I've used their work quite a lot. I will try and cite them as much as possible, but it's harder to do in a talk, but there will be lots of footnotes in the forthcoming chapter. In 2006, Mike Ware made an attempt to sort of scope the volume of Herschel's output. And it's useful because it really brings home the enormous volume of the experiments. So Mike Ware counted 771 different kinds of paper preparation. And these were created between 1839 and 1843. He noted that each paper could be divided into 12 to 16 pieces. And that means that each piece Herschel would then subject to different kinds of exposure, different development, different fixing and or stabilizing regime. And sometimes he would then resensitize pieces of paper in different materials. So you have it in these small individual slices of photographic and or photochemical experiments. even at a conservative estimate of 12, that puts the number of Herschel's photographic bits and pieces comfortably over 9,000. We don't have anywhere near those numbers in the Herschel notebooks, and we're still looking for them, and occasionally new things turn up, which is good. And he continued to produce these, and this was 9,000 just up to 1843. He continued to produce these on and off for more than a decade. If you put together all the years that he worked intensively on photography and wasn't sidelined by something else or ill health. And I just want to say that of these enormous thousands of photographic productions, very, very few of them were pictorial. So it's not a very important part of Herschel's consideration of this photographic chemistry, making pictures. He does do a little bit of that, and they tend to be the ones that are reproduced more often. But in fact, he was just very, very interested in the reactions of different kinds of chemistry. And I think this stems from his wish to find general laws that would apply to chemical experiment. He never did successfully do that, but I'm going to go back to the very beginnings and show you what I think Herschel is doing and run you through a few experiments in this short talk. And hopefully we can have a discussion about how this might fit more generally into the impetus in the 19th century to attempt to regularize chemistry and give it some theoretical underpinning. So as early as 1813, Herschel was deeply invested in his early notebook, which I don't know if you can see it, but this early notebook says that these are experiments on various subjects, that is optical, chemical, and nonsensical, and queer things miscellaneously arranged for the benefit of posterity. And I think that we should all actually title our notebooks this way. It would be pretty appropriate most of the time. He was using Babbage's laboratory much of the time. And when he wasn't using Babbage's laboratory, many of the entries are about making these experiments with Babbage. And I think that connection is something that I would like to explore much more. And especially because Herschel then inherits Babbage's way of conducting these experiments. And I don't know enough about how Babbage conducted experiments or what kind of equipment and materials he had, but I think investigating that would help me to understand how Herschel started out and his initial training in photochemical experimentation. So I pulled this one out because I was interested in how Herschel was creating his own silver nitrate. And here is an entry from 1814 about making silver nitrate himself. The extolized is crystallized. So you can see that he's melting down commercial pieces of silver. I take it to be coinage, and dissolving it in nitric acid and sort of creating, after washing, trying to get the copper out and creating some crystals, and some very pure nitrate may be obtained. And I'm interested in his distillations, his chemical distillations, but I think I'm going to talk a little bit more today about the electrochemical work and his attempt to find or use much more pure materials. But this is a very early example of Herschel wanting to create very pure nitrate. So it's something that he's very interested in already in 1814. By 1819, he started publishing a series of 3 articles on the hyposulphurous acids. And this research formed the basis of his knowledge for the use of hyposulphites. And we all know that in 1819, Herschel tested the dissolving and precipitating powers of hyposulphite on lead, silver, mercury, a number of other substances. In 1820, Herschel published again, this time on the refractive power of hyposulphite of soda and the silver nitrate of lead. And his knowledge of and interest in the refractive power of the chemical combinations also underpinned his later photographic experiments on vegetable colors and various metals. I'm not going to talk about the vegetable colors today because Caroline Lange, my very able and talented doctoral student, is currently working on vegetable colors and recreating some of Herschel's experiments for her PhD. And hopefully in a year or two, when she's finished and it's all published, you all get to read about that as well. By the middle of the 1820s, Herschel's experiments in precipitation of different metallic and hyposulphurous compounds dominated his chemical investigations. A typical experiment from 1825 goes a little bit like this, and you can see that he's using ferrocyanide of potash to precipitate nitrate of lead. These sort of combinations are things that can be found in very many experiments by various scientists, both in Britain and in Germany, and I'm sure in France and in other places. I'm just now trying to understand how widespread this sort of experimentation is, but it is very clear that at least in Britain, this kind of knowledge and this kind of activity was something that many different scientists were using. That would be very interesting to sort of compare practices between sciences and scientists, and I'm sort of hoping that Frank will have some observations about Faraday that will nicely map onto this, not to put you on the spot or anything. But he noticed this combination decomposed his metallic salts, and he's very interested in colors, Herschel. And this runs through all of his notebooks about many of his subjects. So he has here blue for the persalts of iron, brown for copper and uranium, white for manganese, mercury, cesium, and lead, and green for nickel. And he goes on to describe with a great deal of precision the exact kind of coloration differences going on. This was something that was very common among early photographic practitioners as well, to discuss the color of photographic materials. And Herschel takes this as he's very interested in understanding whether color or not is some kind of stable category by which he can measure his chemistry. Understanding the stability of color for him is very, very important. It comes out in a very pronounced way in his discussions of vegetable materials. In the end, it does turn out that color is not a stable category for Herschel and does not subject itself to any general laws in any way. And this creates a kind of tension throughout all of his experiments from the early days to the later days. You can constantly see Herschel coming back to the notion of color and attempting to reapply it in a way that can either be standardized or at least in some way anticipated when certain combinations are put together. I hope to have a more in-depth and detailed analysis of color, but it occurs so often in the notes and notebooks that it's actually a little bit difficult to understand what it is that he's doing all the time. So in this case, of course, I was very interested in the persalts of iron, which of course turned Prussian blue, which got my attention as a photohistorian, but also because I want to talk about cyanotypy later, and in part because I want to talk about the electrochemistry, but I'll get to that in a moment. So they can't really be relied on as an inherent quality of any of his experiments or any of the outcomes of his experiments. But even as he's established the inconsistency of color, he continued to investigate it, the nature of color, by noting every color change in all of his experiments. And as I said, they're very extensive. I'm not sure I understand what he thinks is happening, but I'm hoping to make some sense of them eventually. So the research on hyposulphurous acid and its compounds and Herschel's interest in color change laid this foundation for further chemical investigations by light, heat, and chemical intervention. Herschel never did electrochemistry, not that I can find anyway. In 1831, he added to this knowledge a substance that was new to him and found amongst his father's chemicals, which he called platinate of lime, that is calcium chloroplatinate. that could be darkened in the presence of light. And Larry Schaff has written about how Herschel demonstrated in his book, Out of the Shadows, which is a wonderful book. I can definitely recommend it, especially if you're doing some summer reading. And Herschel demonstrated this experiment where he precipitated metal salts using violet light, and in fact, a little stencil as well. It's all in his notebooks, to Babbage and Talbot and Brewster, all in 1831, and several others that are not named, who gathered at Babbage's house for breakfast on the 21st of June, 1831. There's a wonderful excerpt from Larry's book that you can read for that. Leading up to this demonstration, throughout March and April of 1831, Herschel also explored the effect of colored filters on the experiment. And he made these sort of filters in different ways by dissolving various metals, including the tincture of roses. So it's some of the earliest use of his vegetable colors was for making colored filters in which to do this experiment. And Herschel's investigating these properties as filters becomes his later investigation of the properties of vegetable colors in general. So what's really interesting about these, and here is the page that we know because it's Larry Schaff reproduced this, but I just wanted to show you. This is notebook 3. Sorry, I should have put that. Notebook 3 from the Science Museum notebooks. The effect of light and determining the precipitation of platina by lime. And that's in the left-hand side in the notation, but you can see the little vials that he was using. And down in the right-hand corner is the experiment with the vial that you see on the left-hand side drawn in with the platinate of lime being stuck inside of a colored solution to use it as a filter, a colored filter, to allow him to experiment with different kinds of colors. Oh, I was supposed to give you here. I'll have to move this a little. It didn't really work the way I was hoping. So on the next page, which is really interesting, he started trying to think about these experiments and substances in a class all of their own. And here you can see the large page, and I've cut out an excerpt, which is from the bottom half of the page here so that you can see it. And in here you can, I don't know if you can see my cursor, but in the notation here, you can see that he's renamed this substance the photoplatinate of lime. And what's interesting to me is he begins to actually think about light a little bit like gravity or mathematics as a kind of stable, defining general law to apply to a whole class of objects. Now, we all know that this didn't go anywhere. We don't have photoplatinate of lime, sadly, because it's a lovely name. And I'm interested, though, in Herschel's sort of wish to impose the notion of light, just like we might impose as a kind of, what would you call it? I guess, as a whole class of objects. What's really interesting about this is that on the next page, Herschel also comes up with a photoplatinate of silver in another experiment, where he begins precipitating with both platinate of lime and silver nitrate, photographically speaking, using violet light, specifically violet light. We don't have a long time today, but I could run you through these experiments. What's really interesting, though, I think here is his notion about naming these as a class of objects. By 1832, after considerable advancement in his understanding of the action of light on chemical substances, Herschel applied a general title called photology to describe the whole set of experiments. And it's a word that he applied, that had been applied now and again to studies of light, and one that Herschel even suggested to Talbot in a letter of 1837. But I think it's because Herschel was already thinking about his own experiments as being a class of chemical experiments in and of themselves. And to Herschel, naming is a very important category. Those people who've read the preliminary discourse will understand what naming is for Herschel and how important a move it was for him to begin classifying something under a name. And I think he's doing more than just creating a taxonomy. I think he thinks that he's coming up with a theorization of this particular area of chemistry. And he's trying to elevate his chemical experiments from the perhaps apocryphal Rutherford statement of it being mere stamp collecting. And I know that chemistry during the 19th century had some difficulties in being considered a proper science, as it was in some way put in service to so many other sciences. And I'm interested in how Herschel thought that identifying this class of materials was going to help him do that. So if we turn now to the cyanotype a little bit, and I'm going to make this last part really short because we started a little late and I want to have a discussion about it. The history of the cyanotype has been really thoroughly explored by Mike Ware and Larry Schaff, mostly, and some others, with good reason. Under its more common name, the blueprint, it became the dominant method of industrial and architectural copying for nearly a century. The details of the invention are very much entwined with parallel innovations made on experiments in electricity and the growing industrial use for synthesized chemicals. By 1839, photography had arrived on the heels of almost 40 years of electrical research in Britain and elsewhere. Recent research by Martin Jurgens and Joe Gain have both highlighted the sort of nexus of electrical research and the daguerreotype, both in creating daguerreotype plates, as Joe Gain is investigating, but also in later creating daguerreotype copies, as Martin Jurgens is investigating now. The combination of electrochemistry and researches on electricity and photography haven't been well researched yet. But it is clear that especially through the 1840s and 1850s, these two things came together quite productively. And I think on some other people are also investigating electricity and photography, and it will be very interesting in the coming years to see what kind of relationship those two things have. We know that there were many more industrial chemists. The Royal College of Chemistry in London was, of course, a major driver of that. Herschel got his materials from Alfred Smee, who was a surgeon and a chemist working for the Bank of England. And it was he was the perfect example of a sort of industrial chemist whose knowledge in chemical activities directly supplied materials for Herschel's photographic experiments. And Mike Ware already suggested Smee, and as has Larry Schaff, as a major driver for some of Herschel's experiments. There are quite a few letters exchanged between Smee and Herschel, and Smee himself was a photographic practitioner. In his daughter wrote a memoir. And in it, he describes his early attempts at photography. We sadly don't have any of Smee's photography, but we do know that he was making photographic experiments. For Herschel, Smee created the potassium ferrocyanide that Herschel needed to make the cyanotype in 1842 by applying electricity from a battery that he had invented to a preparation of iron. So he was synthesizing potassium ferrocyanide that was in a very pure form out of potassium ferrocyanide, as he called it. And this soluble potassium ferrocyanide appeared under different names in Herschel's notebooks. You see it as red ferrocyanate of potash or ferrosesquicyanurate of potassium, something you should never try and say live on YouTube without a health warning. And these reoccur throughout his notebooks. Smee provided Herschel with a sample from this in the spring of 1842, and on using it, Herschel produced many, many papers with a strong blue impression, which led to a number of different recipes for the cyanotype. There was never one set recipe that Herschel used. There were actually a series of recipes that Herschel brought together for what he called he considered the cyanotype to be not one thing, but again, a whole class of processes. And he was very interested in these classes of photographic processes. It's again, it seems to me to be harking back to his initial attempt to call these photoplatinates of lime and of silver, a new class of chemical substances. We know also that because Herschel was dealing with very pure substances and he was working in close contact with chemists who were able to supply him with these materials, that he was working right at the cusp of the new industrial chemistry. And we all know about William Hyde Wollaston's use and creation of extremely pure platinums, which later would move into photographic platinum printing, but also for many other uses. And these kind of, mostly we've discussed the cyanotype as an invention of Herschel's, but in fact, we see that without Alfred Smee and his industrial and especially his electrochemistry, that Herschel's ability to create new photographic processes would never have occurred. And it's very important for us to consider that Herschel went on to consider many of these new processes and products in different capacities. And here I just wanted to show you some of the one of the notebooks in the HRC. This is from the Spectrum from quite late in his life, the late 1850s. Herschel took up the study of these materials again in the 1850s and into the almost to 1860, and began using them not just as photographic materials, photographic emulsions or sensitive materials, but as developers. And here you can see in 1291, Herschel using some kind of an iron salt. I haven't fully deciphered what this one is, and very, very importantly, developing it by gold. So he's going back to some of his very clear experiments and reusing those materials, not as sensitive salts, but as developing salts in the 1850s. I think we've more or less run out of my 20 minutes. So I want to wrap up by saying, I think that taking Herschel's experiments as a whole from the 18-teens right up to 1860 shows us that he's not that interested in making photographic images. He's not at all interested, actually. Occasionally, he has moments where he's interested in making photographic images. He's much more interested in trying to understand these salts and the reactions of them as a whole class of materials. And I think in trying to understand whether or not light can be applied as a general as a stable category to understand whether or not there can be some general laws to create about these actinic chemicals or these photoactinic chemicals that he is working on and working with. He never comes to any definitive answer, and in fact pulls quite a few published papers or papers that he intended to publish because he had no general laws to expound upon. And I think this is another reason we don't know these experiments as well as we know some of his other work, because he was very skeptical about the ability to extrapolate them into larger general laws about chemistry by the end of the 1850s. And I think I'll leave it there.
Thank you, Kelley. That was really, really interesting. And I learned an awful lot about Herschel, I have to say. So I'm going to exercise my chair's normal prerogative and ask the first question. Those of you who want to ask questions, you could put your name in the chat box and I'll then call you more or less in order. I was really interested in what you were saying about the use of the word photo, as in photoplatinate of silver, photoplatinate of lime, because that reminded me very forcibly of what the very young Humphrey Davy did in 1798, where in a sort of 17-year-old attack on Lavoisier chemistry by a very obscure provincial aspiring poet, later chemist. Davy proposed replacing Lavoisier's caloric with what he called phosoxygen, and the PHO stands for light. So he's basically saying oxygen doesn't actually exist as a chemical element in the way that Lavoisier says it does, but it actually combines with light, the PHO bit, to produce phosoxygen, and that's one of the sort of basic building blocks of chemistry. And Herschel obviously knew Davy, though one has to say that by that time Davy was deeply, deeply embarrassed by this teenage theory, and it seems to have gone around trying to buy copies of his book to sort of suppress it. But I do wonder in that, where that sort of phraseology, that sort of aim of using light as that sort of in that sort of categorical way, somehow Herschel come across Davy's work.
I have no proof, but like you, I think that Herschel knew all of Davy's work. And even if he hadn't known it very well, by the time he was, even if he'd forgotten some of it, I do sense that he is interested in that proposition, even if taking it up slightly differently. There are also indications in his correspondence with Brewster, even though Brewster didn't publish on this, about the use of different words, or the use of different types of light as a categorization. And they go round and round in a few circles about their circumlocutions and about not using this for that and trying not to use different words for the same thing. And every once in a while, something comes up that indicates that they're also trending in that direction. Nothing concrete, unfortunately. But I think it would be interesting, actually, I'll go back and reread that early Davy paper. And maybe as these... as more notebooks come online, as I transcribe more of what's in these notebooks, there'll be more indications that might point in a more concrete way towards what Herschel intended. This excerpt is the only one I've found, and it occurs in a very short space of time,
right,
to do with some very specific experiments, and they don't come up again. He never. And for a long time, in fact, I doubted my reading of it. I went back to make sure it wasn't proto and not photo. But after looking at a few mentions of it, I decided it definitely says photo. And you're absolutely right. I find it interesting. And it was an attempt that he didn't come back to, except that he later comes into this idea of photology as the whole area of study. And that must, in the 1830s, have been his general idea, that there was an area that you could categorize and have it discrete from other areas.
Thank you. Okay, so I've got one new message. Let's see if I can find it. Stephen Case.
Hello. Hi, Kelley. Can you guys hear me all right?
Yeah, great. Hi, Steve. How you doing?
I'm doing well. Thank you for that fantastic talk. I really appreciated that. I don't know a whole lot about the history of chemistry during this period, so I'm really excited to hear about your project here. And specifically, I'm interested in what you find about how widespread the sort of thing that he was doing was at this period of time.
Mm-hmm.
I've got lots of questions about how this maps onto his optics, but I'm sure Greg probably wants to ask some of those as well. So I have a really specific question about the cyanotype.
Okay.
So often when Herschel comes up in, I don't know, just sort of popular web searches, he's attributed as the inventor. And I hear it often said that he invented it for a specific reason because he wanted to reproduce some of his notes. And that doesn't sound right to me. I think that's sort of reading back what we use blueprints for. But I was just curious if you had seen anything about that, or I mean, I think you're much more accurate. He's interested in, the processes, not to do a certain thing, but to learn about light and about the chemicals. But I was just curious if you had heard that and if it was correct.
My own sense from looking at this much of Herschel is that Herschel never used photography. People in his family did. If people made cyanotype copies of his notes, then it was most certainly his daughter, I would guess, having been trained in the cyanotype later. Herschel is not at all, the cyanotype is not at all invented to do anything. He asks Smee and it's written out very clearly in the notebooks. There's a really clear couple of passages. Larry has talked about it too, that he asks him for these very pure chemicals because he has already been working with ferrous materials, and he knows that ferrous salts do have reactive, are reactive in light. And he asks him because Smee says to him, oh, I've got this new stuff. It's very pure. I just distilled it. And we don't know enough, sadly, about Smee because he's still a bit of a mystery. And I wish we knew more, but even in all the digging, I still haven't found enough about him. But at the same time, it's very clear that Smee provides it. It might be part advertisement. Smee's a businessman. He understands the importance of his new electrochemical process. And off the back of this new engine that he built, he actually published quite a bit on electrochemistry of this sort. And this was a very new product from his brand new engine and to me, it looks exactly like that. Oh, I've made this new iron compound. I think it would be really sensitive. And Herschel said, can you send me some? He sends some. Herschel makes beautiful, as he calls them. I think the phrasing was beautiful, very dark, or very, very dark and beautiful blue color. He's interested in the color and how reactive it is. So it's nothing to do with copying. He's not thinking about practical uses of it at all. And as far as I know, Herschel never made any cyanotypes except when he was demonstrating the process.
Thank you.
Okay. Greg has just put a question in the chat box because he has laryngitis. So I shall read it out. He appreciates, Kelley, that you're broadening the view of Herschel's chemistry beyond photography. On the question of the non-fixed nature of color, it might help to look at his work on crystalline optics. Crystalline optics and the spectrum in the early 1820s. There he doubts Newton's one-to-one alignment of color and refrangibility, for example. This might give you another angle on color in his thought. Photology, I think he used the word in a letter to Whewell around 1830.
Thanks very much for the reference to that letter to Whewell. I'll go and look it up. Yes, Herschel was very interested in discussing color with both Talbot and Brewster, and I'm very indebted to Larry Schaff, who gave me his transcriptions of the letters between those three, where they are discussing the double crystalline structures and double crystals and all that. Talbot then publishes on it a bit on it, and so does Brewster, and they're trying to regularize the terminology, and color comes into it very much in those discussions. I didn't bring that in here because it felt too tangled already, but you're absolutely right. I should bring those together and consider them side by side as they go along. You're absolutely right. They must be connected.
Emily Hayes has a question.
Hi, Kelley. Thanks very much. I was wondering if you could tell us a little bit more about the sorts of light that he was experimenting with, and whether he used a magic lantern, even with experimental work on different types of paper.
No, not to my knowledge. He was using all natural light. He would divide it. And Caroline Lange has done some fantastic work in recreating Herschel's prismatic camera, which looks amazing, and has been making these spectra, remaking them. And what we're learning about Herschel, and he notes it very clearly in his notebooks, that he was he would divide the light. So he is using ultraviolet light from the yellow end of the spectrum, et cetera. So he is trying to isolate certain bandwidths of light, but all natural light. he's not interested in, as far as I know, light from the oxyhydrogen microscope yet. He does do some analysis. Oh gosh, Steve would know better. There was this whole thing about Herschel and whether he analyzed light from stars. And Steve has a little section on that in his book as well. But as far as he was very interested in natural light, and he knew that the ultraviolet end of the spectrum was going to be the most reactive. And many of his things are made using his prisms. He had several different prisms in use and natural sunlight.
Any other questions? Because I've got quite a lot myself. Keep us going for a while.
That was my intention, Frank.
Yeah. So, bearing in mind that Babbage and Herschel studied the mathematical tripos in Cambridge, which at that point was not noted for its chemistry content, and still isn't noted for its chemistry content, come to that. How did both of them actually come to know so much chemistry, learn the sort of really quite sophisticated manipulative techniques that are required?
That is a really good question, and I don't know the answer. And they're really sophisticated. So Herschel's drawings in these notebooks, especially in the notebook 1, of the kind of apparatus they were using, are very sophisticated looking retorts, and his drawings are really beautiful. I especially like it when he's sort of draws things burning, because they really look very hot. You know, Herschel was such a good draftsman. It seems to me that Babbage must have learned it first. Even in the early experiments, Herschel seems to have done all of his experimenting. All of the earliest experiments I can find have been done at Babbage's or with Babbage, which indicated to me
in Dorset Street.
I can only assume that's where his laboratory also was, unless he had a different one, but I sort of assumed, yes.
No, that would be a reasonable assumption, certainly.
And I wonder if they learned it from one of the many chemistry manuals that was around. Brand would have been published and available in many editions, actually, before they began.
But I think
I
learning chemistry from books is not straightforward. I think you've actually got to go and sort of see and work with someone to sort of learn that sort of sophistication of chemistry. Now, Brand in the 1810s and 1820s was lecturing at the Royal Institution, which isn't 1,000 miles from Dorset Street. So I suppose it's possible that Herschel but we certainly know Babbage actually became a professor of mathematics at the RI briefly at some point in the 1820s. Herschel, by 1825, had come to know Faraday, not particularly well originally, over the project to improve optical glass, which is a very stressful project for everybody concerned.
I wonder a little bit about Herschel and glass, now that you say that, because of his interest in optics and his knowledge of the glass manufacturing, or lack thereof, in Britain, and that being such a hot topic, I sort of wondered myself if that was the way he had gotten into chemistry, in trying to understand glass manufacturing. Steve's got a point to this. I think
I think Greg is typing, so he's probably okay. Here we go. So I think the glass comes later, but early on in Cambridge, he is working with specifically Clark. He's doing mineralogical analysis for Clark. And in fact, if I think I have my dates right, it's Herschel puts himself forward for a chair of chemistry at Cambridge fairly early on.
That's right.
He doesn't get it, but he's like, if it had just come vacant a couple years later, I would have established myself enough that I could have done that.
You're right. I'd forgotten that. It's interesting too, because Wollaston is so much involved in electrochemistry too. And that's a connection that perhaps needs further looking into. Thanks, Greg.
I mean, Greg also comments that sort of Babbage and Herschel worked with Wallace and Tennant Clark, that's presuming E.D. Clark, and I'm not sure who Davis is. Do you mean Davy, Humphrey Davy? Okay, fine, fair enough.
Yeah. And it strikes me that this is part of that network that we need to understand when we think about Herschel. So we've talked about Herschel in chemistry very often in relationship to his relationship to Talbot, mostly because Larry Schaff and Mike Ware have done such extraordinarily good work in deciphering Herschel's writing in that direction. And it's not easy to decipher, and there's a lot of it. But drawing back this network will, I think, reveal quite a lot about the atmosphere in chemistry and in chemical training going on at the time. And Talbot, too, benefits from some of the, yes, absolutely, Steve, we should look at Herschel's work on polarization and the experiments in Paris with Arago. And that network, I think, should be drawn larger in order for us to begin to understand. You come to this narrative and Herschel is fully formed and says, aha, I have hyposulphite and we can fix photographs. And that's all that's been dealt with Herschel. And I think there's a much more complex story about the networks of these chemists that explains a lot about, at least for me as a photo historian, 1839 and what happens then. Herschel also worked with Faraday on optical rotation in a high voltage helix as early as 1821 or 22. He did?
That's news to me, I have to say. Would you like, of course, Greg, you can't talk. So
He's got laryngitis.
It failed.
It failed.
Rob, did you want to say something?
Well, I've just noticed it in Wikipedia of all things. There's a note that says that Herschel and Babbage went to France in 1819 to the French Academy, and I just wondered if some of their private stuff, some of their stuff came from there. Perhaps that's where they may have picked up some of their methods.
It's entirely possible. I think that's what Steve was indicating with Herschel's work on polarization with Arago and his knowledge of what Arago was up to, because it's Arago and Fresnel were doing these kinds of experiments already. And I think Arago even published by 1815 using light sensitive materials to try to understand the decomposition of them by light at the time, and they were very advanced, some of those experiments. So yes, absolutely. Travels to France.
I mean, thinking about Fresnel, I mean, the other person in that sort of London network is Thomas Young.
Yes.
Who's always lurking around there. I mean, he's not much of a chemist, but he's very interested in optics and color fringes and all that sort of thing, and polarization. Yeah. And he turns up as secretary of the board longitude, involved in the optical glass work in sort of late 1820. So there must be some sort of link there.
There must be. What I'm kind of interested in too is how, while I can see that the early work is probably very connected to optics and crystals and all of that, it seems to me that during the 1830s, he begins to conceive of this actinochemistry as its own category of things that is not about optics, interestingly. So he begins to kind of separate it off. And this is where I think his use of photo, if we go back to that,
right,
becomes really important for the 1830s. His use of photo whatever becomes a kind of indication that he thinks, here is something that isn't optics, which is what I've been working on before. It is something else, and it needs a kind of general categorization. But I also think that he thinks of it as perhaps showing him some fundamental laws, or in the hope that they will eventually show him some fundamental laws.
Do you think it's significant that when Herschel writes his enormously long essay on the Encyclopedia Metropolitana, he calls it the essay on light rather than the essay on optics.
Oh, I guess I never thought about it. Always imagined that they had commissioned him to write an essay on light, and therefore he did. But
I've got no idea what the commission was. Authors have been known to ignore commissions.
I would never do such a thing. Yeah, that's a good question. Do you think at the time of the Encyclopedia Metropolitana, it would have been more usual to call it an essay on optics as opposed to an essay on light?
Well, I'm not quite sure, but I mean, it's more optics than light, one has to say.
There are quite a lot of optics in it, yes. Yeah.
Stephen, you want to say something?
Well, I was going to bring up that exact treatise, right? That he's working on that during this period. I hadn't thought about the title though. I think that's a really good point. I do think we have that famous line that he writes to his wife that he's like, light is my first love. This is what I'm interested in. And he doesn't say optics. He doesn't say optics was my first love. So I think Kelley, you are right to get at sort of this idea of he wants to understand light, right?
And I wonder if it's because he can tie it, as you say, he can tie it back to mathematics. So to him, you could understand that the tie back to mathematics opens up the opportunity to associate with fundamental general universal laws, which is, of course, Herschel's always, I think we always have to remember that that's what Herschel's after. He doesn't always achieve it, but with all of his experiments, that seems to be what he's after, to get at the general physical laws of the universe and somehow make them.
If just following on from that, if one was being really speculative, one could suggest that he was trying to do what Newton had failed to do, because Newton wrote the sort of highly mathematical Principia and highly qualitative optics, and bring the two together. Because Herschel, I don't think he never says it in so many words, unlike sort of Davy, who does see himself as a new Newton, and if he had that sort of synthetic view of bringing the two great Newtonian sciences together, that would make a certain sort of sense.
It really would. And Herschel is very humble, but at the same time, extremely ambitious. So it wouldn't surprise me at all that he thinks it's absolutely possible to do this. And that makes for interesting speculation.
Okay, any final last questions before we draw things to a conclusion? Stephen, was that you? Yes, please.
I'm sorry, just really one quick comment to what you were saying, Kelley. I think that idea of light embodying the mathematical laws, right? So when he's working on polarization, I can't remember where it is, but he talks about, he's projecting polarization patterns, and he's like, the equations, you can see like the literal equations sort of geometrically in the light. So he's very excited about that. So yeah, I think you're absolutely right.
Yeah, I think you're right. I didn't bring up morphology. I'm still, but he's very interested in the way morphology can help him tie things to a mathematical explanation. And the way he does that with his weird continuous curves as well is quite funny. I mean, it's slightly bonkers, the whole thing, but I love that he understands that by projecting these and allowing many people to sort of observe and perhaps even compute the morphology of particular curves, that he will come up with some kind of constant that will explain all of these different things to a whole audience all at the same time as well. Yeah, I love his projective work. It's really interesting. Oh, and orbits of double stars. Okay. I hadn't ever looked at those. I kind of avoided them, but I'll go and look at that too. That's really interesting. Yeah.
Okay, any last questions, points, comments before we call it a day? Okay, well then it just remains for me to say that the next seminar in this series will be on the 28th of September, same timings, when Gabriele Ferrario will be talking about the Book of Atoms and Salts, and that will be mark the occasion of the publication of the second issue of the Ambix supplement, which is called Sources. The first volume having been published more than 10 years ago, we're sort of trying to speed up. So this will be, that will mark that publication. Seminars like this don't happen of their own volition. One has to fight against the technology like Eventbrite. And so I have to thank everybody involved in so many ways in getting these seminars up and running. And that's Rob Johnson, Anna Simmons, Caroline Cobbold, Becky Martin, Chris Campbell, and Joe Hedison. This seminar will appear shortly on the SHAC YouTube channel. So if you want to hear Kelley again, do go and this discussion for that matter, do go and hear her. And so, but last but no means least, thank you, Kelley, so much for giving such a really, really good seminar. Thank you.
Thanks, everybody. Thanks for all your input and suggestions. I will take this further. And I really appreciate the conversation. Those were really interesting questions and discussion, and I have a lot to think about now. And thanks for the invitation.
Okay, and have a good evening, stroke day, stroke night, wherever you happen to be around the world.